Hi, my name is Ying Zhao. I'm a research professor from Navy Postgraduate School. The topic of my talk is simulating a logistic enterprise using an asymmetric wargame with Soar reinforcement learning and coevolutionary algorithms. This is a collaboration with MIT CSER Lab and Northeastern University and colleagues from US Marine Corps. So the so-called leverage AI to learn, optimize, and wargame a complex enterprise with LAILOW method is to meet the challenges and needs of US DoD and Navy. So Navy include Marine. Basically, their requirement is coming from the operation concept, such as distributed maritime operations and expeditionary advanced base operation. So this requires the capability and manpower and equipment and materials to be ready. So this concept of readiness involves a lot of business process and data. So they also need, of course, analytics. So when there's a data, data mining, machine learning, and predictive models can be applied. So also because it's involved the business process and course of actions, decision making. So there's need optimizations. So when there's a new data, especially there's new situations or unknown situations, there's no data. So simulation and wargame are important for this complex enterprise. So use case is from marine maintenance and supply system, and data is about land armored vehicle, this equipment in a few years of the data. So basically it's like a trouble tickets for this equipment. So we aggregate it in the ticket level, and the target variable to predict is the probability for the time between the deadline, which is a time to decide if the problem is critical, to the close of the target is less than the average. Okay, so we use some predictive models, include Soar reinforcement learning, which is a machine learning algorithms to predict this probability. And also we divided the business process into the so-called attacker variables or test variables and defender or solution variables. So attacker side basically are variables that they are cannot be changed in terms of the solution side. So they're like how long you use the equipment and location, defects, etc. But the solution side will be the things that the actions or decision you can actually change. So like, you know, if you put a spare parts and which and where to send the things to fix, and transportation, so on. So this war game is basically this attacker and defender game, also is a test and solution game. So in the middle of this, the machine learning algorithm, the reinforcement learning is used to predict the fitness for coevolutionary algorithms used for the optimization of the two sides. So basically the fitness are asymmetric, so they sort of looking at a measure of performance, but they're pulling into two different directions. However, they're not necessarily have to be a zero-sum game. So here's the visualization comes out of this wargame model. It's called CoEvSoarRL. So basically, it's an illustration of how the defenders and attackers evolve from starting to the end. So here shows 3 generations, and starting with the database and so on. So all those cells has information. So if you drill down, look at the detailed data, that will be showing different cells. So basically all this is starting with database data that is a particular configuration of the problem, or the solutions, what's the fitness look like. So that's the one data that people saw before. So after the evolution, basically attacker will be getting higher fitness and found something that's not in the database. So this one may be more feasible, which means it might really happen in real life, although it's not in the existing database yet. So, but the other one, maybe you found something has a really high fitness for the attackers. However, they're probably less feasible because the actual business rules that involved in those variables. But nevertheless, this demonstrated as a framework and with machine learning, reinforcement learning, and jointly with the coevolutionary algorithm, be able to apply to the real life data to looking for the vulnerabilities and resilience. So vulnerabilities will be the risk side, and the resilience will be the solution side. So that can be applied to many kind of those complex systems. So this is just example for the logistics. So our future work is to look at this context-dependent information to be able to check the feasibilities of test and solution. That's what we should. Then there's a correction on the score to sort out the final the final heat map of visualization. So also we're looking at the sensitivities of each of those dimensions. So we thank our sponsors, Navy Research Programming, NPS, and ONR, and the Air Force AI Accelerator at MIT. So those views and conclusions are the authors, doesn't representing any component of the United States government. And thank you.